And I put your earbud on top of your paper. Did you find it? There was one earbud still on the desk, and I put it on top of your paper. Uh-huh. That's not yours? Okay. All right. Was that yours? Okay. Sorry about that, Ryan. All right. Rational exponents. That's what we're looking at. So rational exponents are fraction exponents, and rational exponents are how you write if you have a radical. So if we had, let's say we had the nth root of a, the way that we would write that is we would say that we had a to the 1 over n power. We would have a to the 1 over n power. And then if we had the nth root of a to the m power, that would be the same as a to the m over n. They're both with the a, if that makes sense. So actually, that was actually a good question, because there's two ways you could write this. Another way you could write this is you could say the nth root of a raised to the m power, and it looks the exact same. It would still be a to the m over n. So that is also this. Okay, so the first thing that we're going to do is we are going to write in radical form. And once we write it in radical form, if we can simplify it, we're going to. Okay? So for the first problem, we're going to do x to the 1/4. So if the exponent is 1/4, then what type of radical is that? It's a 4th root. So this would become the 4th root of x. And we can't simplify the 4th root of x. There's only one x in there, so we're done. Okay? If we were to do 15n to the 1/2, this is saying that the 1/2 applies to the 15, it also applies to the n. So it applies to both things. And what type of radical would a 1/2 be? It'd be a 2. And what type of root is that? It's a square root. So we would say square root, we don't even have to write the number with it, because a square root you don't typically write the 2. And it would be square root of 15n. And if you were to try to simplify that, break down the 15, would you be able to get any pairs out of 15? No, you'd have a 3 and a 5. They'd both be singletons, no pairs. And then with the n, you just have one n. It'd just be a singleton. There'd be no pairs. So this is as simple as it can be. We can't simplify that anymore. Okay? Let's try this one. If we had 24 to the 1/3, what should we write? Okay, so this is going to be a 3rd root of 24. And can this one be simplified? Yes. Okay, so 24 is what times what? 2 times 12. 12 is 6 and 2. 6 is 3 and 2. Okay, so because it's a 3rd root, we are looking for triples. And then we got a leftover 3. And so what is our final simplified answer? So, yeah, which one goes on the outside? So the triple goes on the outside. So 2, 3. Yeah, so 2 cube root 3. 2 cube root 3. Okay, let's try 7 to the 2/3. Okay, what type of root do we have? Cube root. Okay, and do we know what 7 to the 2nd is? 49. So this is the cube root of 49. If we were to break down 49, would it be something that we could simplify within a cube root? No. If we broke it down, it would be 7 times 7. That's a pair, not a triple. And so it's not beneficial for us to do that in this situation. Okay. So cube root 49, I'm going to leave it just like that. Okay. Let's try this one. We're going to do k to the 7 halves. So what type of radical? Square root. What's inside? A k to the 7th. Okay. Now, can this be broken down at all? We can put it into groups. So I'm going to have 1, 2, 3, 4, 5, 6, 7. And I'm going to look at how many should be in each group. 2, it's a square root, so I'm looking at pairs. There's 3 pairs and 1 leftover. It'd be square root k because of the leftover. What about the pairs? Do I write 3k? I write k to the 3rd. Okay, so k to the 3rd square root k. All right. Let's do 3 to the 5/4. 3 to the 5/4. Okay, so what type of root am I going to have? I'm going to have a 4th root. Okay, what goes inside? 3 to the 5th. Does anyone know what 3 to the 5th is? $243? Okay. How'd you know it was 243? Handy dandy calculator. 243. Uh-huh. Ooh, okay. That sounds like more mental math than I'm capable of. Okay. Now this, though, the nice thing about this is that 243, we know it's 3 to the 5th, right? That's 5 3s. We don't even have to do a real factor tree with it because we know it was 5 3s. So we would have a quadruple, a set of 4, and a leftover. And so what should our final answer be? Three, 4th root 3. So the quadruple goes in the front, the singleton goes underneath, and it was a 4th root. 3, 4th root 3. Okay? Okay, we've got A and B to the 3/4. A and B to the 3/4. Okay. What type of root is that? A fourth root. Okay. Yeah, so we have to think about what we should put underneath, because we have AB to the third, so should we do AB to the third, or should we do A to the third, B to the third? A to the third, B to the third? Okay. These are both correct, by the way. They're both accurate, but I do think this one is better, because it shows that you understand how the exponents work. Does that make sense? Neither one of them is mathematically wrong. They're both mathematically correct, but this one shows an understanding of the exponents. That we understand that the exponents go to both the A and the B. So I would say A to the third, B to the third. Okay. So if it's a fourth root, can we simplify the A's or the B's? No, because there's only 3 of them, so we're done. Okay. All right, this one's kind of interesting. Negative 6x to the 2/3. Okay. What type of root do we have? Okay, cube root, third root. Okay. And then, okay, negative 6x squared. The squared has to apply to each of these, right? So what is negative 6 squared? 36. Okay. And then what would the x be? X squared. Okay. Should we break down the 36? Okay, because a 6 and a 6 would be 2, 3, 2, 3. There's no triples there. I'm going to break it down just so that everybody can see it in case that was hard to visualize. So 6 and 6 would be a 2 and a 3, a 2 and a 3, which is no triples. And then the x squared is an x and an x, which again is no triples. So all of these would end up staying underneath, which means it was as simplified as it could be. Nothing more we could do. Okay. I think that is a good place to maybe let you guys practice some. You guys feel like you could do some of those? Yes? Okay. So I'm going to hand you guys a worksheet to practice, and you're going to do 1 through 6 are the problems that are like this. So you're going to do 1 through 6. Okay. All right, we ready? Okay. Now, for the next type of examples, we're going to write. Oh, that's right. No, I forgot I froze it. We're going to write in exponential form. We're going to write in exponential form. And I would say typically, the only time you typically simplify is when you're doing the writing in radical form. I guess they would have to specify in the instructions that they wanted you to simplify. I didn't write it down, but I'll prove it to you. The instructions for this one said simplify if needed. The instructions for the examples we're about to do don't say that. So we can go back up here to our notes and we can say simplify. But the reason you're going to like these next problems is because we're not going to simplify them, which is going to make the problem go way faster, because the simplifying part is the terrible part. So here is our first problem. for writing in exponential form, we have a cube root of 16. So if I need to write that in exponential form, how would I write it? 16 to the 1/3. Easy peasy. Okay. Number 2. It's nice. We got the square root of xy. Square root of xy. xy to the 1/2. And we're going to put it in parentheses because we're going to make sure that the whole xy, that's a group, and that group has the same exponent of the 1/2. If you had not put the parentheses, if you had written xy to the 1/2, what you really would have been saying is you really would have been saying x to the 1, y to the 1/2. So you have to put the parentheses because you have to say that they're both getting the 1/2. Yeah. The parentheses are important. Yeah. Okay. Here's the next one. We're going to do 4th root of 8w. Parentheses around the 8w and then to the 1/4. Okay. This next one, we're going to say 3rd root of 11 squared. 3rd root of 11 squared. 11 to the 2/3. 11 to the 2/3. Okay. Next one, we're going to have the 4th root of k. I'm going to write this one funky. K to the 5th. This is a funky one. What? Yeah, this is k to the 5/4. And the way you can remember is the root is always the one that goes on the bottom. So the other one has to go on top. That's just how it goes. Yeah. Yeah. And because Aubrey had asked about this. And so we added it to our notes. It was less common, but we did add it in there. Yeah. It means the same thing. But if you don't like it, you can go like, I don't like that notation. Let me rewrite it. 4th root, k to the 5th is actually the same thing. But you don't need the parentheses if you do it this way. Same thing. K to the 5/4. Okay. Let's do another one. Square root 3m to the 7th. Okay, 3m. Does it need to be in parentheses? Yes. Okay, to the 7/2. So the radical is always the bottom part. The type of radical is always the bottom. Okay. All right, this next one. Because both of these were underneath the radical. So if both of these were under the radical, they both get the exponent. Okay. All right, now this one is going to be interesting. We're going to do square root of 10 to the 5th, a to the 3rd, b. So should this one get a parenthesis? No, because they all have different exponents. They'll have different pieces. So they're going to have something in common. Well, the xy, let's look back at the xy. The xy technically had a 1 and a 1. That's the same exponent. See the difference? A 1 and a 1. The 8w had a 1 and a 1. The 3 and the m had a 7 that was going to apply to both of them. See the difference? We could put parentheses around it because the same exponent was going to go on top. Now these, this one has a 5, a 3, and the b technically has a 1. Okay, so anyone think they know how this one should go? So it'd be 10 to the 5 halves, a to the 3 halves, b to the 1 half. So we can't do parentheses because the top is different for all of them. And if we did parentheses, we'd have to figure out some way for the top to all be different, and we can't do that. Yeah. So no parentheses on that one. Okay. Let's try this one. Third root of 9 x to the 7th, y to the 4th.
Okay, with the last one, if we got like 2 over 4, would we simplify that?
Mm-hmm. Yep, good question. So if anyone didn't hear that, Whitney's question was, if you get a fraction for an exponent and you can reduce that fraction, should you? And the answer is yes. If you get a fraction for an exponent and you can reduce the fraction, you should. Okay? All right. All right, so what should I have here? 9 to the 1 over 3, all right. X to the 7 over 3, okay. Y to the 4 over 3. Okay. All right, so the homework for tonight is going to be on the worksheet 7, 8, 9, 10. 7, 8, 9, 10. Okay, now, you cannot leave yet, you cannot pack up yet, because it has come to my attention that that my enrichment class has not filled out a form that we have to fill out because the counselors need it. So it is on the Google Classroom. Some of you did. I'll read your names. We'll do the name of shame. This registration form, it's underneath Unit 1. Registration form, it's important. The people who have not done it are Aubrey, Quante, Gavin, Kylie, Gracie, Itzel, Ryan, Shelby, Martha, Kayla, Amari, and James have not done the form. The counselors want you to do the form. You have to do it, because if you don't do it, the counselors are just going to randomly assign you electives for next year, and that will be very, very sad. Even going what? Your meeting is probably just to make sure you're on track for graduation and stuff like that, and to make sure you sign up for the right things and look at your core classes and make sure if you flunked out of year-long English, you didn't sign up for AP English, that sort of thing, just to make sure that they're double-checking everything.